Given the advances in computer graphics hardware, we have the opportunity to significantly improve user interfaces by developing 3D virtual workspaces that tap human experiences and capabilities. After all, people deal very effectively with our interactive 3D world, not just 2D virtual desktops that can easily run on 10-year-old computers. However, 3D virtual workspaces support tasks that require new interaction techniques. A case in point are tasks that involve large amounts of information, such as a description of a building. People need to move between global orienting views and detail working views. The problem is, this movement needs to be both rapid, so that work time is not lost, and controlled, so the viewpoint can approach close to target objects without collision.
This video describes two viewpoint movement techniques that are part of a multiple virtual workspace system called 3D rooms. The first technique uses virtual joysticks associated with the icons in the center of the window to walk around the room. We use it to illustrate typical problems associated with rapid, controlled, targeted viewpoint movement. This example shows the problem of controlling 6 degrees of freedom with 2D input controls. Imagine the user wants to move to the second line on the whiteboard. First, the walking joystick is used to move close to the wall, and then the arrow joystick is used to move up to the desired spot. This example shows the problem of controlling high velocities. The workspace is an interactive floor plan of Xerox PARC for finding people and their offices. High velocity results in a rapid approach, but it's easy to go too far. Backing up and trying again is time-consuming.
The solution is to have the user indicate a point of interest on the surface of an object and use the distance to this point of interest to calculate a logarithmic motion function. This time-distance diagram is used to plot the resulting motion. The viewpoint moves from the origin toward a viewing region near an object at distance d. The motion is initially rapid and then slows so that there is plenty of time to stop while a viewpoint is in the viewing region.
This example demonstrates the point of interest viewpoint movement technique. The mouse cursor is used to indicate a point of interest on the surface of an object, which can then be adjusted. The distance to this point is used to calculate a logarithmic motion. With a simple key press, the viewpoint moves through multiple degrees of freedom and asymptotically approaches the object. Another key moves the viewpoint away. Point of interest movement can be used to zoom in to see detailed information, as in this floor plan, and to zoom back out for orienting views. This example demonstrates automatic adjustment to the point of interest surface normal for better viewing. When both movement keys are pressed, the viewpoint hovers over the surface and allows the user to examine the details.
Logarithmic motion can also be used in object manipulation. However, the user must be able to control object position at a distance. The solution is to use an acceleration motion clipped by a logarithmic motion. As before, the time-distance diagram has the object start at a distance d from the origin where the viewpoint is located. In this case, the object moves slowly at first, allowing control at a distance, then accelerates toward the viewpoint, and finally moves logarithmically slower for control near the viewpoint.
This example demonstrates the logarithmic object movement technique. In this case, the mouse is used to grasp objects and move them in a plane parallel to the viewpoint. A key press first accelerates the object along the ray to the viewpoint, and then, as it approaches the viewpoint, the motion becomes logarithmically slower. Moving the object away accelerates it. Controlled motion at a distance can also be accomplished. Logarithmic motion and object movement allow rapid, controlled movement over multiple degrees of freedom and scales of magnitude, with only a mouse and 2 keyboard keys. The techniques can also work with multidimensional devices, such as the glove. Point of interest movement takes advantage of human perception without being restricted by the inertia of the real world. These 2 techniques provide practical, fundamental interaction methods for designing virtual workspaces.